Let's write a Python BPF program from scratch. So we start by importing. First, we add a BPF decorator. Then we add a BPF global decorator. And then we define a license. We make it into a string. And we return GPL. So this would be the license for our program. And then we let the program compile. Again, we define a BPF section. And in the section, we give, let's say, a trace point of execve. This is the entry point to execve. That we have entered execve and we've returned. Then we compile this program. We see that an object file has been written here. And we could load it now, but I'd like to make a few modifications before we do so. I'd also add a exit syscall. Yeah. So now we see that we keep getting execve enter and execve and exits. Programs give the execve syscall. So apart from this, we also support binary operations. So if I just say a equal to 1 plus 2 and we also support format strings. So if I just write that, that's also pretty feasible. We have an object file written. So you can see that a equal to 3, it evaluates. The corresponding LL looks something like this would be the right one. Debug information, generating it from the maps and stuff. So yeah. This demo showcases the sysync syscall and tracing it and finding out the time differences between the sysync. So first we see we've imported a hash map and we've added the trace point here. The trace point is a string. Then we first look up the key 0. If we find that the key exists, we go to this block, else we go to this block. And in this block, we see that we take the time at which the called, and then if there was a key existing, then we again find the time, then we find the delta of the time, and if the time difference is less than 1 second, then we divide it and turn it into milliseconds. Then we print if sync was called, and then we finally delete the key. So once I write a write Python-BPF 2.py, it's automatically going to compile, and we have an object here. If I run a verification check, we see that verification succeeded, and the program was. We run the program. So to trigger the syscall, we go into a Python REPL. We import OS, and then we do os.sync. I leave a second. Then again do os.sync. I leave a second, again do os.sync. So it does not work. But then to trigger the program, we had a condition of around a second. So if I make very quick os.syncs, we can see that our program responds very well. We could change this into 2 seconds and recompile and reload. And now our timing is better. So as you can see, now the limits have increased to 1 second. And this is the XTP demo in particular. So we then compile PyBPF1.py, that's the first example. Then we get an object file, PyBPF1.o. It does. First we define a hash map with one entry and in 64 key and value both types. Then we have an XGP section. We first look up if a key exists. If the key exists, then we increment the key and then we show the key. And then this is triggered when a packet enters the computer through a particular interface. So then we update the key with the incremented value, and then we pass the packet. If the key does not exist, then we create the key. I'm going to load this particular program on my Tailscale interface. So as you can see, it has XGP generic loaded onto it. QDisk with uh, QDisks have also been loaded. So now home node is a computer on my Tailscale network. So if I ping my computer, it's supposed to increment the counts here, and then it's also giving out the packets as we have passed the packets. Now I can choose to drop the packet. Let me recompile it. And now if I ping my home computer again, the packet counts increment, but the packets don't come don't come back to user space. They just terminated in in kernel space. If I have a previous value of 10, if my number of packet count reaches 10, then I'll start dropping packets. But before that, I'll allow packets now. Let's recompile and let's load it. And now if I ping home node, we can see the counts. The counts increase to 7, 8, 9. And once it reaches 10, the number of counts keep increasing, but the number of packets don't come around back.